Welcome to math class. We are moving forward in our unit on shapes, and we are going to be looking at composite perimeter, circles, and Pythagorean's theorem. Don't get scared, Pythagorean's theorem is much easier than everybody makes it sound. All right, so what we're going to start with is composite perimeter, or what happens if we got a funky looking yard and I got to build a funky looking fence. All right, so I have a drawing on the board, unfortunately with very, very terrible resolution quality. So it's hard for me to see exactly what those numbers are, or sorry, hard for you to see exactly what those numbers are, but all of my numbers are, as best I can tell, because the copy I have is much better, my perimeter equals 4 plus 7 plus 4 plus, oh, it's hard to tell what that one is. Looks like that's a 2 plus, looks like our last number there is a 9. So even though it's funky shape, it's still the same thing. I just have to add up all my distances. So I've got 11 plus 6 plus 9. 11 plus 15 is going to give me 26. Let's double check and see what our answer there was. Oh look, 26 centimeters. Perfect. So let's go ahead and look at another example. What if we have, oh, I'm going to skip ahead there. What if we have a funky shape like this? Now I'm going to rewrite these numbers so everybody can see kind of what they mean. So the numbers we're dealing with here is we've got a 13 over here. Our little side in there is a 9. And down here on the bottom we actually have 11. Not sure if you heard that, but an announcement just came on, but we'll keep going anyway because it's too hard for me to go back and edit videos. So what I've got to figure out, and this is a bit of a tricky part here, everyone looks at this picture and goes, all right, I've got 11 across the bottom here, but Mr. Waldo, they didn't tell me how big each of those ones are. Guess what? Doesn't matter. Okay? I know that this one plus this one plus this one is going to equal 11. The reason I know that is because this shape across the bottom here, this whole distance, is 11. So these three edges are all going to total up and equal 11. Now I also know what these two inside edges are because they told us exactly what they are. And I know over on this side it's going to be the same as the far side, so I know that that one is 13. So what I wind up with is 13 plus 13 plus 11 plus 11 plus 9 plus 9. Add all those up, I get 26 plus 22 plus 18. 26 plus 40 gives me 66. For a final answer, double check, awesome, 66 centimeters. So what we have to remember there is they are not going to give you so much information you can't go and do the question. But you are going to have to look at the information they do give you and start thinking about how it applies to some of the other spots on the shapes. Okay, let's go ahead and take a look at the next one. Circles. How do we figure out the perimeter of a circle? After all, there are no sides to add up. Okay? Now, Mathletics is actually jumping us into looking at parts of a circle right off the bat, so it's a little bit trickier, but it's not any more difficult as far as the math goes. We have two equations we need to work with. C equals pi d, or C equals 2 pi r. And what that means is the circumference, or the perimeter of a circle, is known as the circumference. My messy writing on the smartboard is the circumference. So the circumference is going to equal pi times the diameter. Now the diameter of a circle is the total of the width across the circle at any point, because we know that it doesn't matter where I am in a circle, if I draw a straight line from one point to another, it's going to be the same all the way across the circle, unless we aren't actually cutting the center of the circle and we're doing weird stuff like that where I'm cutting down on the side. But that is a conversation for another day. So a diameter is all the way across. A radius is halfway across, or the distance from the very center of the circle to the outside part of the circle. Anywhere on that circle is going to get the same distance. We know that that is 15 centimeters because they've told us that. So I'm going to go ahead and use this equation since that's the number I know. C equals 2 pi r, which means 2 times pi times 15, because that is the radius they gave us. So if I go ahead and pull up my calculator here, the way I'm going to punch this in is I'm going to go 2 times, now I'm going to go ahead and find my pi button on here, pi times my radius, which is 15, and that gives me a final answer of, sorry, whoop, lost my calculator there, 94.2477, a bunch of change. So we're going to round that up to 94.25. Now that is the circumference of the entire circle. But you'll notice we only have half of it. All right? So I'm going to immediately divide this number by 2. When I do that, what I get is, well, let's pull up our calculator. I'm going to take that same number, I'm going to divide it by 2, and I get 47 point, what did we have on there? Let's round this one up, 0.12. Now this particular question gets a little bit tricky because, I don't want to show the answer here, but because I've figured out exactly what the circumference of half of the circle is. So I figured out a shape that looks something like this. But I haven't added up the piece of the shape that actually closes the half of the circle, which on our diagram is this one over here. Now 15 centimeters is the radius, so it's halfway. That means my other half here is 15 centimeters. So I actually have a total of 30 centimeters. So I'm going to add 30 to that, and I'm going to get an answer of 77.12. And if we go ahead and check our answer, we see that, look at us here, 77.1. So we actually could have rounded up for another decimal space. And let's take a look at another example. Same thing, but instead of half a circle, oops, we only have a quarter of a circle to work with. And again, since we have a fuzzy number, they're giving us 3 centimeters as the radius. So I'm going to go ahead and follow the same equation I did last time. C equals 2 pi r, which is 2 pi times 3. So I'm going to go pull up my calculator and punch that in. 2 times pi times 3 gives me, I'm going to say 18.8. I should probably do my rounding correctly. Oh, 18.9. I'm actually going to switch that up a little bit. 18.9. Now I know that this is 1/4 of a circle. You have to forgive my also not to scale drawing, but I know that this is 1/4. So I'm actually going to divide this by 4. I'm going to get a total of, let's pull up our calculator, divide by 4 equals 4.7. 4.7. Now, I also have to, now that I've figured out exactly how much that distance is, I also have to figure out how much this distance and this distance is. I know that this one's 3 centimeters, And I know that radiuses are always going to be the same, no matter which point on the circle they get to. So I know that this one is also going to be 3 centimeters. So I'm going to add 3 plus 3. I'm going to get 4.7 plus 6, which is going to give me 10.7 centimeters. Let's go ahead and try this out. 10.7. All right. We managed to do it. One more example. All right. We looked at circles. Now what happens is if we have a triangle. Now we're starting to mess around a little bit here with Pythagorean's theorem. Okay. Now, Pythagorean basically determined that in a right angle triangle, so any triangle that has a perfect right angle, side A squared, if you added it to side B squared, is going to give you the length of C squared. So what we're going to do is we're going to show you a little example how this works. So let's going to pretend that this side is 3, let's say centimeters long. This side is 4 centimeters long. We need to figure out how long is that side. Well, I'm going to use my handy dandy Pythagorean's theorem formula. So A squared plus B squared equals C squared. So I plug in the numbers that I do know. I know A and B. 3 squared plus 4 squared equals C squared. I'm going to go ahead and solve these. So I know 9 plus 16 equals C squared. Well, I know that 25 equals C squared. I need to isolate and get this C by myself. So I need to do the opposite of squaring it. So what I need to do is I actually need to square root 25 and C squared. And what happens there is I get C and the square root of 25. If we punch it into our calculator here, so I'm going to clear this. I use this symbol over here. So I go square root of 25 equals, 25 as a square root equals 5. Depending on your calculator, that order might be a little bit different. Now what that means is C squared, 25, the square root of 25 is 5. What that means is 5 times 5 equals 25. Okay. So the way I figure that out is I punch in everything that I do know, and then I have to solve for the one value I don't know. So let's go ahead, scroll down here, and we're going to take a look at another example. Now we're going to pick some slightly gnarlier numbers to work with here. So I'm going to go, let's say 9 and 16 over here. So I've got to pull out my equation again. A squared plus B squared equals C squared. I need to know what C is. I know what A is, 9 squared, plus I know what B is, 16 squared, equals C squared. 9 times 9 is 81. I can't remember exactly what 16 times 16 is off the top of my head. 256 equals C squared. 81 plus 256, according to our calculator, is 337. So 337 equals C squared. Now, I have to go back here, and I actually have to punch in 337 as a square root. So I need to put this symbol over my 337 and over my C squared. And what I get is 18.4. 18.4 equals C. So this side is 18.4. Okay? That is Pythagorean's theorem. Now, how does that help us figure out perimeter? Well, I'm glad you asked. Let's take a look at an example like, oh, I'm losing my slider bar here. Take an example that looks like this. So I'm going to rewrite these numbers so you can see them. They've got a 9 up top here, 15 over here, and 17 down at the bottom. We don't know what this side over here is. So I've got to do a little bit of Pythagorean's theorem to start this off. So I know how far this side is. It's 15. I know that this section is 9, and this section is going to be 17 minus 9. So I know that my a squared plus b squared plus c squared, equals c squared, is going to wind up with 15 squared plus 17 minus 9 gives me 8 squared, equals c squared. So if I punch all of this into a calculator, all right, 15 squared plus, oops, sorry, didn't want to put that in there, plus, oh, I think I've screwed up my calculator here. Let's try this again. 15 squared plus 8 squared equals 289. All right, so I've got, let me grab the right color pen, 225 plus 64 equals c squared. Our answer was 289 equals c squared. I have to square root both sides. Pull up our calculator here. So the square root of 289 is 17 equals c. So now I know that this side is also 17. Now to find my perimeter, I add all sides. So I get 15 plus 17 plus 17 plus 9, which gives me 15 plus 9 plus 34. 24 plus 34 is going to give me 58 centimeters. We go ahead and check our answer. Look at that, 58 centimeters. So go ahead and try the next few on your own, and I will see you in class.